So I'm going to talk about JavaScript architecture today. Apologize for my voice, it's a little scratchy. So yeah, in case you don't know, I write a lot of books, and it's not because I'm actually better at my job than anybody else is, it's because my memory is really bad, and if I don't write stuff down, I forget. And so then I just put that into books, and if you don't have those around, you should buy copious copies of them. So when we talk about JavaScript architecture, a lot of times people just start talking about MVC. So that's the hot term right now in JavaScript is, oh, MVC, do you know JavaScript architecture? Well, I do MVC, so I obviously must know JavaScript architecture. And that's all well and good, except that doesn't tell you the whole story. So just to place this, how does that look now? Oh, good. It's actually less washed out on your screen than on my monitor. Awesome. So in case you've been messing around with MVC, maybe you've been using Backbone, stuff like that, I just want to put this talk into context for you. So I'm going to be focusing more on the C part, the controller part. And that's partially because this is the part that people usually get incredibly wrong. There's all kinds of ways of dealing with models and views, and they're actually not all that complicated, no matter how you choose to do it. But the controller part is incredibly complicated when you don't put some thought into it. And this is usually the area that I see people making a lot of mistakes. So again, I'm not talking about MVC, but in the context of MVC, I'm talking about controller stuff. And what I'm really trying to get at is building an application framework. You can think of an application framework like a playground. It provides some structure around activities that aren't usually related, but are kind of similar. So the swing and the teeter-totter are not exactly the same, but you put them on a playground together and you keep your kids busy for the entire afternoon. It's a great idea. So isn't that what JavaScript libraries do? A lot of people say, well, you know, I'm using a framework. I'm using like jQuery, I'm using Dojo, I'm using YUI. Those are actually libraries, and those function like toolboxes. So there's all kinds of little tools in those toolboxes that you can use to build whatever you want. But it's not a way to build an application on its own. Right? You still have to tie those pieces together into some sort of logical order in order to make it work. There we go. So you can think about that library as being at the base of your application stack. It's the lowest level thing. And then you build your application core on top of that. So you want those base utilities there. They're very important. But you need to add another layer on top in order to keep things well organized. And that's when we talk about modules. So modules mean different things to different people. So pay attention. I'll explain to you what it means to me and what it means in the context of this architecture. But you think about modules as part of an application, I like to think about everything as being a module on its own. So again, if you were to ask somebody what a module was, you'd get a bunch of different definitions. So when I looked it up in the dictionary, I got all of these different ones. And most of them are kind of boring. But the one that kind of jumped out at me was this one. An independently operable unit that is part of the total structure of a space vehicle. Okay. Which is awesome. So let's talk about space vehicles for a little bit. This is the International Space Station, hovering precariously over us, hopefully not degrading in orbit. It's giant. It's huge. And yet it's up there in space, fully functional, working really well, we think. And how do they do that? Right? Like, it's actually really hard to get something off of the Earth into outer space. So space shuttles have those gigantic thrusters that they use in order to break the atmosphere and get into outer space. And that takes a lot of energy, and it still is only getting something that's smaller than most commercial airplanes up into orbit. Right? A lot of energy for a very small object. So then how do you get a gigantic space structure into orbit? Well, the answer is that you separate it out into modules, into small pieces. So you can take each of those small pieces and shoot them up into orbit, and then combine them in outer space. So you've now broken down the problem that was previously massive and complex into a much smaller set of problems that are a lot easier to deal with. Because any one of these modules can be shot up into space on its own. It's much, much smaller than the entire thing. And because it's done in this modular fashion, that also allows you to split up the work. Not everybody has to be working on the same thing. And not only that, not everybody who's working on a module has to even be sitting together, talking to each other. All you need to know is what's the correct interface for that module. And then when you get them into outer space, assuming everybody was building to the correct interface, you can add them together and you can create this giant structure. And so what they actually did, and it's a little bit washed out here, is they separated out all of these modules across different countries, because they wanted to be international space stations, so all the different countries could contribute by building one or more modules. And so in yellow here, that's everything that the United States built. But then you have some stuff that Japan built. It's a little bit hard to see, but there's a little like crane thing here that Canada built. That was their addition to the space station. Like Italy down there. The ones that you can barely see over in the corner, that's Russia. That's pretty cool, right? Because you had people working on this at all corners of the Earth, each building their own thing, and then shooting it into space and combining it with everybody else's. And that's the way that I like to think about web applications. Right? That if you're building a web application that is giant, it's going to end up as a big mess. It's just the way that it happens. You may or may not have experience with that already, but that is what happens over time. It just grows larger and larger and larger, harder to manage, and then all of a sudden things fall apart and people say, well, we have to start rewriting it. Well, if you think about web applications in this way, and you think about web applications as being made up of modules, you might think of a web application module as an independent unit of functionality that's part of the total structure of a web application. So what does that mean? Well, if you were to look at my Yahoo, which I'm sure that you do every day, it's actually really easy to look at this and say, okay, I can see where the modules are, right? Because they're all in boxes. It's really easy to see, right? Those are modules. You have weather, you have top stories, scoreboard, stock portfolio, all of that stuff, very easily identifiable as modules on the page. But what if you go a little bit further? Can you find other ones on the page? Maybe you would say that's one, maybe that's one, maybe that's one, maybe that is. It really doesn't matter. You can slice it up in all kinds of different ways, as long as you're keeping functionality grouped together. So if you think of these modules, they each consist of HTML and CSS and JavaScript, right? Just like the overall web application does, each of these individual modules have the same makeup. And any single module should be able to live on its own. This was one of the things that I pushed very heavily on when I was at Yahoo, was when you build these things, you should be able to take it and stick it onto an empty page, and it should still work, regardless of if there are the other modules that were normally around it there or not. You shouldn't get errors. It should still be able to do its job. So loose coupling allows you to do that. Right? When you have these modules and you're keeping them nice and separate, they can each do their own job, and they don't need to know about other modules that are on the page in order to do what they need to do. And each module has its own little sandbox, and that's basically an interface that allows the module to do things outside of itself. Because at some point, it's going to have to do something that it can't do on its own, and it will need some help. And so there's a sandbox that the module is allowed to play in order to do its work. And so we saw this a little bit earlier. If you have your application stack, you have the base library at the bottom, the application core at the next level, and then the sandbox on top of that. So it's acting like a filter to what the application can actually do, so that the module is just allowed to do a subset of that. And then you can have any number of modules kind of hovering around there. They're not related to one another necessarily, but they're all part of the same solution. Now, modules have limited knowledge about what's going on in the application. That's on purpose, because if they know too much about what's going on in the application, they're able to break the application really, really easily. By limiting a module's knowledge, you prevent that module from being able to break everything else without you trying really, really hard. So each module only knows about its sandbox that it's playing in, and that's it. the entire rest of the architecture doesn't exist for them at all. And so this is just a very quick and easy example of what this might look like. Throughout this, I have small code snippets. I don't have a large example to show you, and that's on purpose. Partly because when you show people code, they tend to get wrapped up in the code and not think too much about the structure. And partly because I've never been at a place where you could do this and it works here and it also works somewhere else. There's always some requirements that are unique to your application that just don't fit for anybody else. So you take a look at this. Basically, you would have a module name and then some function that you use to create an object that represents the module. And you can pass that sandbox object in so that then you can use it. And you may want to have built-in methods like init and destroy or create and dispose, whatever you happen to like. So which parts of the web application actually know about what's being built? Well, none of them do, because everything is more or less self-contained. You can think of each piece of the application as like a puzzle piece. Right? The puzzle piece doesn't know what the picture is that it will eventually be displaying, and it doesn't matter. Right? As long as that puzzle piece fits in the correct slot, it has the right interface, that means it's doing its job, and ultimately the picture will become clear. And so what is the module's job? Well, if you're the weather module, then it's your job to tell people about weather. And if you're the stocks module, then it's your job to tell people about the stock market. And basically, each module has a job that it's supposed to do for the user to create some sort of meaningful user experience. And there's something that that module is supposed to be doing that nothing else is supposed to be doing. And so the web application is created when all of the puzzle pieces are put together. And when everything is doing its job together in one spot, that's your application. So to talk a little bit more about these modules here. Modules are the spot that contains business logic. The module is the only thing that knows what it's supposed to be doing and how it should be doing it. And so that's where that logic belongs. In order to do that, modules can manage data and views, like we were talking about earlier, MVC. So there's some data that's being managed by that module. There's some view that's being managed by that module. But you don't necessarily have to have objects that represent those. You don't actually have to have something that is an instance of model in order to say that you're using some data. Nor do you need something that's a single object that manages your view for you. You don't have to do that. These are just abstract concepts about what's going on under the hood. And views may use widgets in order to get their job done. So you can think about widgets as reusable pieces of UI that have no business logic in them. And so that's stuff like menus, tabs, carousels. These are things that you can use over and over again in the same application. And they have UI logic. Right? They work a certain way. Tabs work a certain way. Dialogues work a certain way. Carousels work a certain way. But they're not tied explicitly to the data that they're displaying or that they're interacting with. So you can reuse those actually in multiple modules if you want to. So module A can have a tab view, module B can have a tab view. That's fine, but they're both putting different data into that tab view. That's the important part. So you can actually build up this widget toolkit that can help you construct views within your modules. Now, modules can't do whatever they want in order to do their job. Again, if they're doing too much, that makes the entire application fragile. And so you want to keep them limited as much as possible. So I like to think of these modules as being like little kids. Right? As you sit them down in a corner and you turn your back, and then you come back and oh my God, they're into everything. Right? It's like you didn't even notice, but now they're under the sink, they're in the cleaning supplies, it's just a mess. They're listening to your iPod. It's horrible. And so just like with kids, you need to have some rules. And so first is hands to yourself. You only call your own methods or those on the sandbox. You don't reach out of that in order to do other things. And that's where you start getting into tight coupling, and that's where things tend to break. Don't access DOM elements outside of your box. A lot of times a module is represented by a single DOM element that has just a bunch of stuff inside of it. Right? And there's no reason for that module to reach outside of that element in order to do its job. That is a good way, however, of messing up other stuff on the page. Don't access non-native global objects. So non-native global objects would be things like window or document. And stuff like that that's floating out in the browser environment. As soon as you start touching those, you're affecting everything else that's on the page, and that can be really dangerous. So ask, don't take. So if you need anything more than what's on the module itself or on the sandbox, then you need to ask for it, to request permission for it. So that prevents you from doing things that you shouldn't be doing, and also allows some really nice stubbing out possibilities for testing. Don't leave your toys around. Right? Don't just start creating global objects everywhere, because again, you're messing around with the environment that everybody needs in order to do their job. And don't talk to strangers. So don't reference these other modules directly. And that's a great way to make sure that you'll break a bunch of stuff when anything changes. So the modules have to stay within their own sandboxes, regardless of how uncomfortable that is. And it's very uncomfortable, I'm not going to lie to you. I've used this architecture at Yahoo. I've used it with a bunch of my consulting clients. And the first thing that happens, people kind of go like, yeah, that's cool, like we can do that. And then they start using it, and they're like, wait a second. What do you mean I can't touch document? What do you mean I can't touch jQuery? Like, I can't do my job this way. I'm going to quit if you make me do it. That's not an exaggeration. People have actually told me that. And on their way out the door, I said, well, that's too bad. But there's a reason for this. Right? Constraints help to keep things where they're supposed to be. And constraints also are a really great way to inspire creativity in people. If you're just allowed to do whatever you want, that's not really a challenge. Right? Like if you were forced to sit here and you were told, you will be doing what Nicholas said later on, maybe half of you wouldn't be here, like you'd be checking on Twitter and Facebook right now. It wouldn't be that cool. Right? But see, my challenge is to convince you that this is a good idea. And so that makes it far more interesting to me. And you can still decide that you don't like it. And that's okay. But the important part of this is just to realize that constraints are necessary so that there can be some sense of order. And that even though there seems like there might not be a way to do something because you're not allowed to do it the way that you're used to doing it, doesn't mean that it's not possible. So let's talk a little bit about this sandbox thing. The sandbox's job is to ensure a consistent interface for the modules. And that's important because your application can change a lot. You're always adding things, you're removing things, you're refactoring things. But you can't have things change when people are dependent on them. And so the sandbox's job is basically to provide that consistent interface that isn't going to change so that you can have everything else change without it breaking the rest of the code. So modules only know about the sandbox. That means that as long as that remains the same, the modules will continue to work. Right? Anything underneath the sandbox can change, and modules will still work. It also acts like a security guard, preventing modules from getting access to things that they shouldn't. And this is really helpful in testing. Right, so let's say that you have in a module, you wonder if you can house cheeseburger. Right? That joke's a little bit dated, but it still works. You're asking for permission. Right? Can I do that? And if so, okay, then I'll continue on and do some other stuff. And that's the basic idea behind it. This is something that I wouldn't normally be able to do on my own, so I'm going to see if I'm allowed to do it. And if so, I'll continue on. Obviously, I'm not recommending this sort of interface. There's a number of different ways you can do it, but the idea is the same. So what's the sandbox do again? Consistency. The interface has to remain the same so that the modules can continue to work. Security, so determine which parts of the framework a module can access. Communication, so translate module requests into core actions. And in a lot of ways, the sandbox is like a filter. So it's filtering out everything that the application is capable of doing and only exposing to the module a smaller subset of that. And you want to take the time to design this interface correctly because you can't change it later. You can't just start changing methods whenever you want. You can always add things, but you can't change them. Because when you change this, that means that all of the modules have to change. And one of the big ideas behind this architecture is that you should be able to make changes in one spot without needing to make changes everywhere. So let's talk about the application core. This is actually ridiculously simple. All it does is manage modules. That's its only job, is to keep track of the modules that are available and work with them accordingly. So you may also call this the application controller if you prefer more of the MVC terminology. So the application core is responsible for module lifecycle. It basically says, this is when you're going to start, and this is when you're going to stop. One of the big problems I see when going into companies that are using like jQuery, for example, is that everybody starts attaching stuff onto document ready. And then all of a sudden you have like 25 million things that are happening on document ready. And nobody knows where that's happening because it's in a bunch of different files. And then one thing is actually stomping on what somebody else is doing. And that's a huge mess. So the last thing that you want is every developer attaching stuff to document ready, window on load, stuff like that. It's a really bad idea. On the other hand, it's a great way to make sure that you end up in a huge mess later on. So the application core is really helpful in just telling modules, this is when you're going to start, and this is when you're going to stop. And that becomes more interesting when you think about dynamically loading things on the page. So for things that are on the page at the start, you say, OK, start everything at document ready. But what if you load something after the fact? Well, OK, so that thing can't be done on document ready. When is it actually going to start? Well, I'm not really sure. Maybe we should just stub out document ready, and we'll call it automatically, and that will magically make stuff work. And then you're just making an even bigger mess than before. So making sure that the modules can be started and stopped whenever you want is really important for the long-term sanity of your application. And so this is what some of that might look like. This would work with the code that I showed you earlier. So this is your core. You say that there's a register function, so that takes the module ID and the creator function, and just basically keeps track of it. And don't get too caught up in the actual implementation. It's not that important. But then when you start a module, you say, OK, I want to start this module ID, so I'm going to call the creator, and then I'm going to call a init on it. I'm going to create a separate sandbox just for that module, so it can play how it wants to. And then the opposite. And so when you want to stop something, you can say stop, module ID, call destroy on it, and then clean up any memory that's associated with it. Okay? Very, very easy. And then you may also want to have start all and stop all, because once you load everything onto the page at first, you want to start everything up. And then when you're unloading, you want to stop everything. This tends to be some of the common functions that you end up implementing. And so then your application basically looks like this. I'm going to register all of the modules on the page that are important for my application. And then once they're all registered, I'm going to start them all. And that's all. That's your application. Very simple. Now, the application core also manages communication between modules. So I said earlier that modules can't know about each other and interact with each other directly. But that doesn't mean that they don't need to know what other modules are doing. And so how do you do that without modules talking to each other directly? Well, for that, I'd like to go back to very old Twitter. How many of you used Twitter when it was like this? Anybody? Yeah, a few of us. So we're the older people in the room. It's okay. Adam's the oldest. So basically, I'll take you for a little tour of what Twitter used to look like. And that's what I used to look like. You put in your status at the top, or whatever you want to tweet. Say update. That ends up at the top of your timeline. Over here, it's a little bit blurry, but there's home, which shows you this. Apps like that, which is me. That would change it to the mentions screen, which is basically just this, but filtered with mentions instead of other tweets. Direct messages, favorites, and then trending topics, all of which refresh that, right? So if you start to go through and identify the modules that are on the page, you could say that this is the module, right? That's the module. Timeline's a module. A little about me, there's a little ad, there's menu, the search, trending topics, following. I'm not saying that's the way they actually do it, it's just, it would be a logical way to separate things. And so, if you keep these separate, how would you actually have this application work? Because those things need to communicate with one another. And when you post something, that has to tell the timeline that something new has been posted. And then all the stuff on the right needs to tell the timeline to change its filter. Right? All that stuff. All changes the way that the timeline works. And so they actually need to know what's going on, but how do you do that without having objects talking directly to one another? Well, this is probably what it would look like if you just took a first pass at the sort of old school JavaScript object way of doing things. Is you'd have your timeline filter, so that would be the stuff on the right, that says, hey, I'm filtering the timeline based on this criteria. And so you'd say change filter, and then you'd pass in some sort of filter, and then you'd say timeline, apply that filter. A very logical way to construct things. We have the status poster, so that's the thing at the top that allows you to post your status. And when you post status, it says here's the status, and then it says timeline.post, and that's how the timeline knows that you posted a new status. And then the timeline itself has both of those methods that do something. It's a very common way of arranging things. The lousy thing about that is you have very tight coupling now, right? Timeline filter knows about timeline. Status poster knows about timeline. And so those are tightly coupled. And that basically means that any time you change one of those, you're at risk for needing to change another one. And if timeline happens to change, then you're going to have to change those two others. So basically every change that you want to make is multiplied by some factor. And that factor is how many times those APIs are being used elsewhere. So what would it look like otherwise? So what I'm doing here is I'm using a design pattern called the Mediator, which is like the sibling of the observer pattern. So in the observer pattern, you say, hey you, I care when you do something. So tell me about it. But you need to know directly about that thing. The Mediator pattern says, hey Mediator, I want to know when something happens. Please let me know. But the Mediator itself isn't generating that action. It's not the thing that's doing anything. It's just in the middle. It's kind of like having a radio. You turn on the radio and you say, radio. Okay, maybe you don't talk to your radio, but in your mind you would say, radio, I want country music, or radio, I want rap music, or radio, I want Carly Rae Jepsen. I don't know, whatever. And that's what I'm doing here. Is I have this timeline filter, and when the filter changes, I'm just saying sandbox.notify, so that is broadcasting a message out. This is the type of message that's happening, timeline filter change, and here's the data related to it. So the timeline filter doesn't know anything about the timeline. All it's saying is, hey, I'm saying that the filter for the timeline needs to change. That's all I'm saying. You do it the way that you want to do it. Okay? And the status poster is doing the same thing. When the status is posted, it's saying, hey, a new status was posted. Here's the information about it, just in case anybody cares. So that's very loose coupling, right? I've not violated any of the things I talked about before. The modules still don't know about one another, and they're using the sandbox to broadcast this message into the application. And then all the timeline has to do is listen for those. So it listens for timeline filter change and post status. When that happens, call handle notification, and then do whatever it is that you're supposed to do. So it's very loose coupling between these modules. They're still able to do their jobs, but now if any one of those modules changes, the other ones don't have to change because there's no direct knowledge of what's going on. And so when modules are loosely coupled like that, you can actually remove any module on the page and you get no errors. So if I were to remove the timeline from the page, like I did in this, the status poster still works. So it's broadcasting this message. The only difference is nothing is listening. But that doesn't mean that it's not working anymore. That just means that nobody is responding to the work that it's doing. Likewise, the filters that are on the side, they're still broadcasting their message. But nobody's listening for it. It doesn't change the fact that they're still working the way that they're supposed to. It just means that there's no end user result. And that's really powerful because you can then create modules that are designed to replace other modules. All they have to do is make sure that they're broadcasting the same messages. And so when you go to Twitter now, there's two ways that you can post status. You can do it in the text box that's right on the page, but there's also a dialog that pops up that you can also enter your status into. And both of those could be firing off the same message, which is post status, and the timeline can respond the exact same way with both of them. That's what loose coupling gets you. The application core also handles errors. So errors are usually handled really, really, really badly in JavaScript applications, if they're handled at all. Everybody ends up writing try catch, or they're doing all kinds of things to try to figure out if there's going to be an error, and then there is an error, and you're trying to trap it and trying to log it, and it's really hard because you don't know where it's coming from. The application core can help you out a lot with that. And it can figure out the best course of action to take. Because in development, you actually want to see errors pop up in your face. That's the fastest way to figure out something is going wrong. In production, you don't want those errors to pop up in the end user's face because that's scary and they'll go home crying. You don't want to have errors popping up in front of the user that are unexpected, right? Undefined is null and stuff like that. That's not a great experience for your user. So once again, tons of code here. Don't try to understand it too deeply. You can go check out the slides afterwards if you're interested. But basically what this is doing is when a module is created, it's figuring out if you're in debug mode or not. And if you're not in debug mode, it's iterating over every method on the module and wrapping it in a try catch. And then if there's an error, it's logging it. So just try to execute the method as it was originally defined. And if there's any error, log it. And of course, you can do whatever you want there. Output it to the console, beacon it back to the server, whatever you want. But the important thing about this is you're not relying on every developer to come up with their own error handling scheme. And that's another way where JavaScript applications become a huge mess. So nobody has to worry about writing try-catch for these sort of errors. It happens for you automatically, and then they're logged automatically, and you don't need to worry about it. That's the mark of a good JavaScript application framework. It's eliminating a lot of redundant work that otherwise individual developers would have to do, and replacing it with things that just happen automatically without you needing to do anything extra. It just happens. And if you'd like to learn more about that, I actually did this other talk that's completely just on JavaScript error handling. You know the difference between JavaScript error handling and enterprise JavaScript error handling? You can't do a talk on JavaScript error handling. So they will turn that down. So just to review, the application core manages the module lifecycle. It tells it when to start and stop. It enables intermodule communication through that mediator pattern I was talking about. And that's really important because even though the modules need to not talk directly to other modules, there still has to be some way to communicate. General error handling, so detect, trap, and report errors in the system. And also be extensible. That is one of the jobs of that application core, is it must be extensible. This is the point where I always go, why did I put this slide in? And it's because at the very bottom it says the first 3 jobs are not enough. Why not? Every time. Because web applications change in ways that you can't anticipate. There is no way, like if we put all of you into a room tomorrow, and you said you're building an entirely new application, you would not be able to come up with everything that that application is going to have to do within 2 months. I would give you all of that time, and you would still come away not actually knowing everything that that application would have to do within the next year. It just doesn't happen. And so the way that you do that is you plan for extension from the start. You don't even guess that you're going to get everything right. You assume that you're going to get stuff wrong, and you allow yourself ways to fix that in the future. So plan for extension, because basically anything that's built for extension can never become obsolete. Now, when digital cameras were starting to come around, for some of you, you may be surprised to know that there weren't always digital cameras. There used to be film cameras, which you would have to put this long roll of film in the back, and if you took some bad photos, you were kind of screwed because you didn't get those back. And professional photographers spent thousands of dollars on their film cameras and all kinds of contraptions for them, specifically lenses. So I have a good friend who's a professional photographer, and I almost fell out of my chair one day when she told me that she bought a lens that was over $1,000. So what? Like, it's glass. What are you possibly paying for? Right? But apparently, I don't know if anybody does semi-pro photography, but there's some really expensive lenses out there. And so when digital cameras started coming around, there was an interesting decision made by the camera companies. So they could have been like, well, we want to be cool. We're going to like create an entirely new genre of photography. Right? We're going to have digital cameras, we're going to have digital lenses, and everything's going to be digital. It's going to be awesome. But they didn't do that because you had all of these people who had invested thousands of dollars in camera equipment for their film cameras. So what they did was they created those first generation of high-end digital cameras, the SLRs, with the same bodies as the film cameras. And by doing that, all of the old extensions still worked. You could still use your old lenses. You could still use all of the other contraptions that you had for your camera because the interface remained the same even though the implementation changed. And that's what you're going for when you're building an application, is that things are going to change, but when they change, you want to make sure that you don't have to rewrite everything. You might have to rewrite one part, maybe 2, but you shouldn't have to go back and rewrite everything. So plan for extension. That's one of the application core's jobs. It needs to have ways that you can extend what it does by default. So what sort of extensions? Well, error handling. You might want to have just a generic extension that is the way that you do error handling in the application, because that might change in the future. You might have one system now, you might have a different system later on. AJAX communication, always a big deal to externalize, because you don't want everybody needing to format requests and interpret responses. Get to that in a second. New module capabilities. So it's entirely possible that you will guess wrong about what modules will need to do in the system, and you need to have some way to add that functionality back in. And any general purpose utilities you might want, really anything. This is your escape hatch for anything that you forgot to program in from the start. You have a way of adding stuff in there, and that's important. So let's talk about AJAX a little bit. AJAX communication comes in a variety of different forms. And when I'm talking about AJAX, I basically mean anything that allows you to communicate with the server and get a response back without unloading the page. So that includes XML HTTP requests, that includes WebSockets, server-sent events, anything. That's all AJAX. It's all ways of doing the same sort of thing. Now, the problematic part about AJAX is that there are 3 parts that have to be in sync in order for AJAX to work. First is the request format. So when you are sending a request to the server, it has to be in a specified format so that the server actually knows what to do with that request. Second is an entry point. So there has to be an entry point on the server that's going to interpret that request. And then the third part is the response format. So the server is going to send back some sort of data in some format, and you need to interpret that in some way. So all 3 of these have to be in sync for AJAX communication to work. So that's a great way, that's a great thing to be an extension in your application. So let's say you start out old school, and you have a GET request, and your arguments are just in the query string. And you have an entry point of /AJAX on the server that all of these are going to. And on the way back, you're getting XML as a response format. Now, XML was this data format that was really popular before JSON. It was kind of verbose. But that's the way everybody was doing things. And so if you want to look at that as a basic implementation, you have your XML HTTP request object. And you got a whole bunch of code in there. And if you look closely, you can see those 3 parts. But there's an entry point, /AJAX. There's your request format, so the query string arguments. And then your response format. So all that code in there is interpreting the XML to figure out what to do with it. So you have all those 3 in there. If you're using a library, you might think that the situation is better, because it cleans up a lot of the sort of ugliness of XML HTTP requests. But if you look closely, you have the entry point, you have the request format, and you have the response format. You have those same 3 things that have to be in sync. And bonus, you also have a library reference. And so all of that together needs to work in order for your AJAX communication to work. Compare it to this. And so this is a very generic way of sending data. Now, I thought I had little pop-ups on this slide, but apparently I don't. So I will be the pop-up. So you have name value, and it's just generic. I'm passing data to the server. Then I have success, which is passing in a response that's already been cooked. It's already in the format that the module needs in order to do its job. And then also, if there's a failure, I can handle that as well. And so all of the communication details are completely hidden here. And so why is that cool? Well, when you're encapsulating all those details in one thing that you can swap out, that means I can change how AJAX works for my application without having to rewrite everything. So here I just changed the entry point to /request, and I changed the response format to JSON. And all of the code that is making AJAX requests doesn't have to change at all. I've just changed the AJAX implementation. That's it. So very powerful. Right? And this is actually a transition that a lot of companies went through a few years back, where they're changing everything over from XML to JSON, and a lot of them had to go back and touch a lot of code in order to make that change, which is terrible. It's a huge waste of time. And you can encapsulate that and just swap back in an AJAX extension using JSON. So the AJAX extension jobs, obviously to hide all of those details with those 3 parts of the communication, the modules shouldn't need to know any of that. Provide a common request interface. So whatever you're sending to the server should be generic enough that you're not sending a string, but you're sending a bunch of key value pairs. And a common response interface as well. Same deal. You should be able to get back a series of key value pairs and not need to know about the actual over-the-wire data format. And also manage server failures. So this is something that a lot of people get wrong. And that's because it's a little bit tricky and a little bit hidden. Getting back a 500 or a 404 isn't the only way that your AJAX can fail. There are a bunch of ways that it can go wrong. So yes, if you get a non-200 status code, that's bad. Your request failed. Sorry. But you can also get a 200 back, but you might get an incomplete response. For some reason, the server just cut out. Or you might get a random error inserted into an otherwise good response format. This tends to happen a lot. When I was working with PHP, that used to happen a lot. It's like you were expecting a JSON response, and you'd have like some JSON, and then all of a sudden PHP would puke into your response, and you would get something that was not JSON formatted, and then what you ended up getting back on the browser, you couldn't parse. And so the AJAX extension is responsible for that too. It needs to know if you got back what you were expecting or not. And if you didn't get back what you were expecting, it doesn't matter why, that's still a failure. And it should be treated the same way as like a 500. So the base library, which is where we started, provides a base level of functionality for your application. And that's like your jQuery, your MoTools, Dojo, Prototype, YUI. Those are your base libraries. Right? And they're really, really good at that job. And most of them are really, really bad at doing anything other than that. So most applications are too tightly coupled to that base library. When people decide to use jQuery, like, I want to use jQuery, I want that $sign, I'm going to start using it everywhere, it makes me happy. And that's all well and good, except when you decide that you don't want to use jQuery anymore, that means you have to rewrite everything. And rewriting everything sucks. Nobody wants to do that. It really doesn't matter. And so this guy, Joseph Smar, who's one of the founders of Plaxo, gave this presentation at OSCON in 2007 called High Performance JavaScript. It's absolutely no relationship to my book, High Performance JavaScript, but it was a good presentation nonetheless. And he had this really great line in there, which is that libraries solve more general problems. You should use them like scaffolding. You use them to get yourself up and running, but you don't rely on them for everything, which is what companies are doing now, and that's really unfortunate. Is they're basically outsourcing a lot of important development to these JavaScript libraries that don't understand the business that they're in. And so jQuery has no idea what Box does, has no idea what Yahoo does. And the decisions that are being made there aren't being made with your company in mind. Right? And that's by design, of course, because it's a general purpose library. It has to do a large amount of things in order to apply to the largest number of people. But you can do much better because you know what it is that you're building. And if you'd like to learn more, that's his talk. And slides are already up on SlideShare, so you can go check those out afterwards. Now, ideally, only the application core has any idea what base library is being used. Right? And so why is that? Well, because you could start out by using Dojo and then decide that you want to use YUI. And you should be able to make that change fairly easily without needing to rewrite everything. If you have to rewrite everything, that's bad. It probably won't end up happening anytime soon. And that means that you'll be stuck with your old code for a long time. So what are the jobs of the base library? The number one job is to provide browser normalization. There is no part of the code that you write that should know what browser is being used. That's a waste of time. you should be focusing on the business logic, the thing that actually makes your application work. The thing that makes your application work isn't if is IE, do this, else do something else. You should never have to write that code. So any general purpose utilities, so parsers, serializers, stuff like that, object manipulation, DOM manipulation, AJAX communication, all that sort of stuff. And it also provides a low-level extensibility. So if you have to add something in that needs to know about what browser is being used, you add it as a plugin to the base library. That's where that functionality belongs. Let's talk a little bit about architecture knowledge and what parts know about what other parts. So only the base library knows which browser is being used. Right? The rest of the application shouldn't have to know. Only the application core knows which base library is being used, because it's interacting with it directly. So the core and its extensions will talk to the base library directly to do its job, but nothing else will. Only the sandbox knows which application core is being used. Again, it acts a lot like a filter as to what can happen inside the application. The modules know nothing except that the sandbox exists. They don't know about each other. They don't know about the application core. They don't know about the base library. All of that is hidden behind the curtain of the sandbox. And no parts know about the web application. So remember, the web application is what's made by combining a bunch of modules together. But no single one has any idea about the larger application. So what are the advantages of doing stuff like this? Well, one is that you can create multiple different applications with the same framework. Because if you have that low-level stuff in place, you should be able to reuse that multiple times in order to create different applications. Because each application is just a bunch of modules. So you have a bunch of modules A for one application, a bunch of modules B for another application, and you can use a lot of the same stuff. Each part can be tested separately. So this is another part where companies do a really bad job, is that if you're not able to test things in almost complete isolation, then you're not doing a great job at testing. You should be able to have that one thing existing and poke at it and see what happens without having other stuff on the page. And then when you combine everything together, you can do your integration testing as well. I'm not saying don't do that, but being able to do true unit testing where you aren't relying on external dependencies is really important for the long-term health of your application. And basically, you can think about this like you would Jenga. Right? You can remove any one of those blocks, and the tower isn't going to fall over. That's the important piece. A lot of times, companies waste people's time by needing to go back and change code because somebody changed code somewhere else. Person A decided they had to make a fix, and that required changes in 10 other parts of the application. That's not scalable, and it's not a good use of people's time. So you want the ability to be able to remove something and have everything else continue to work, or replace something and have everything else continue to work. And that's what this architecture does for you. So just a little bit about implementations. When I first gave this talk, which is now several years ago, at the end I was barraged with people saying, well, that's great, but where's the code? Can I play with it? And I said no, and people hated me. Now they hate me for different reasons, but there are some implementations that are out there that people have decided to say, okay, I'm going to try my hand at doing this, and they've open sourced it. Now, I'm not recommending these. I'm just saying if you want an idea about how to set up a system like this, these are some places where you can go to look at some reference architectures. They're all slightly different because they're all built with different ideas in mind, but they're built on the same general premise of having a very loosely coupled architecture with small pieces of JavaScript that can be swapped in and out. Even if they are incredibly generic, they're interesting to look at. So this company, LegalBox, no relation, open source something that they just called JS Scalable app, which is up on GitHub. Go check that out. And they created a nice landing page for it as well, which gives you some quick start and other information about it. There's this one with an awesome logo called Hydra.js. It's also built on the same basic premise. They have a lot more documentation now. There's Kernel.js, which just another one. If you look closely, you can see they kind of copied my diagram at the bottom there. So you know it's good. Actually, what I like about this, I always forget to point out, is that this is 3K. Right? It's very small. And that's how I know that it was done right. Because if you're doing anything more than that, then you have too much in your core JavaScript. There's this larger application framework called Terrifically, which is a combination of JavaScript architecture, a CSS architecture, and a backend architecture. So it's kind of like the kitchen sink of everything combined, which is a little interesting. The latest one by Adi Osmani is called Backbone Aura. And like I said at the beginning, I'm really just talking about the controller part. And so what Adi did was say, okay, if we take the controller part and we combine it with the models and the views from Backbone, how can we create a larger infrastructure? And so that's Aura. And that is the end. So stop. So if you want, there's a lot more information on my blog, my Twitter. These slides are already on SlideShare, slideshare.net/nzakas. So all of the resources that I have in there, if you want to go check them out, all the URLs are embedded right in the presentation. So you can go and continue on. And if you'd like to ask questions, I'm happy to stay and answer them.